Hello everyone, in this video I will show how to plot ROC curve and lift chart or gain chart using Excel. So these concepts are being used heavily in data mining, and I thought maybe it will be very helpful to put this in an Excel and show exactly how these graphs are being plotted. So here is the data. We have actual class 0 and 1. Therefore our response variable is binary. And then we have the probability estimates. These probability estimates are being generated by analytics solver. So we have arranged these probabilities in the descending order. Let's assume 1 being responder and 0 being non-responder. 1 being responder is of our interest. We want to identify as many responders as possible. Here, when you look at the actual data, you see that we have total of 12 ones and 12 zeros. So this is kind of a balanced sample. Here I list the cutoff values, which we will use later. We have a confusion matrix here. So we have a predicted class here. That predicted class could be a responder 1 or non-responder 0. The actual class for the data are given here, and this is coming from the validation dataset. If you correctly identify actual responder as a responder, then that's a true positive. If you correctly identify actual non-responder as non-responder, then that's true negative. If you incorrectly identify a non-responder as a responder, then that's a false positive. And likewise, if you incorrectly identify a responder as non-responder, that's false negative. Sensitivity, which is also known as a true positive rate, is basically the proportion of responders currently identified as responders. And true negative rate is also known as specificity, means that the proportion of non-responders correctly identified. False positive rate, here the formula is given, is defined as 1 minus true negative rate or 1 minus specificity rate. So let's say here our cutoff value is 0.5, and we are going to use this cutoff value to populate our confusion matrix. The predicted value is going to be 1 for the first one and second, and it will be 1 until the cutoff value, and it's going to be 0 after that. Here now we want to calculate the true positives. So that means we are considering responders, and out of responders, how many of them are correctly identified. Let's see the first one. You predict 1 and the actual is 1. So this is a true positive, true positive, true positive. This is not a true positive, true positive, true positive, true positive, and true positive. That's it. Let's count true positives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So here, true positives, we write 11. And now next, we are going to identify true negatives. So our sample is non-responders, and we are trying to find out how many non-responders are correctly identified. So this is not true negative. This is true negative. This is true negative. True negative. And now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the total number of true negatives are 10. And now we are going to find out false positives. So that means actual value is 0, but you identify it as 1. So there is one case here. And there is one case here. That is 2. And now we are going to identify false negatives. That means actual value is 1. But you identify that as negative. So true value is positive, but you identify as negative. We have only one case. So this is our confusion matrix. So we use the cutoff value 0.5 to populate the confusion matrix. Here, true positives 11, true negatives 10, false positives 2, and false negatives 1. We have already found it. Now we will find the true negative rates. So that means the formula is given here. Number of true negatives, which is in this case 10, divided by true negatives plus false positives. Or we want to find out how many non-respondents we have. Here. 10 plus 2. That is equal to 83.33%. False positive rate is 1 minus specificity rate, or 1 minus true negatives, which is 16.67%. And now next we need true positives rate or sensitivity. In the numerator we have true positives, which in this case 11, divided by total number of responders, 11 plus 1. So that is 91.67%. Therefore, we calculated true negatives rate, false positive rates, and true positive rates when the cutoff value is 0.5. We will repeat these steps for all the cutoff values that I have listed here. So we will change the cutoff value 0.6 and then 0.7 and then 0.8, 0.9, then 1, and then go 0.4, 0.3, 0.2. And then for each cutoff value, you will have a different confusion matrix. Based on the new confusion matrix, you are going to calculate TP, TN, FP, and FN, and then sensitivity, true negatives, and false positive rates. So I have already calculated sensitivity and false positive rates for all cutoff values that I have listed on this table. Now we can build our ROC curve. And if you remember, for the ROC curve, y-axis is the true positives rate, and x-axis is the false positive rates. So I'm going to get these two columns and insert a graph. Let's select these two columns and then go insert and then insert a scatter plot. So let's change the range here, and maximum is 1, minimum is 0. And also we want to add our baseline scenario. Baseline scenario is the case where you have 50% of responders and 50% of non-responders in the data. So we are going to choose select data and add. Let's call it baseline. And x values are 0 and 1. Y values are 0 and 1. And then enter. And click OK. Here we can also add axis title. Unfortunately, Excel doesn't calculate the area under the ROC curve, but from the figure we can understand that our predictive model is doing a better job than a baseline model because ROC curve lies above the diagonal line. Let's move on to the lift chart. In the lift chart, basically what we are doing is we are plotting the lift against the percentage of top records. For example, here what I did, I write down all the top records. For example, 0 top record, 4 top records, 8 top records, 12 top records, and so on. And here on the second column, you see that I convert them into percentages. 16.67 is found as 4 divided 24 times 100, which is the percentage of 4 records out of 24 observations. Now we are going to find cumulative true positives using predictive model. For the first one, it's 0. Second one, we are looking at the first 4 top records here. And you see that all of the observations are correctly identified. Therefore, we write it here 4. Now we are going to look at 8 top records. Out of 8 top records, we correctly identified 7 of them. Therefore, we write 7 here. Next, we are going to look at 12 top records. And out of 12 top records, we correctly identified 10 of them. Now we look at 16 top records. And out of 16 top records, the model correctly identifies 12 of them. And for 20 top records, the model also correctly identifies 12. And out of all observations, the model correctly identifies 12. If you don't use the model, then you randomly select 4 records out of these 24 observations. So when we talk about regular or baseline model, we are actually inferring to random selection. What is the probability of getting number of true positives by regular or baseline model? It will be given by the proportion here. We have 12 responders, or total number of ones is 12. And total number of zeros is 12. Therefore, if I randomly select 4 observations from the sample, 50% of the time I will get 1. If we select 4 observations from the sample, therefore 50% of the time, that means 50% of 4 will be true positives. I write it here too. And if you randomly select 8 observations, then 50% of 8 observations will be true positives. Therefore, it's 4. And from 12, 6 of them will be true positives. And for 16, 8 of them will be true positives. For 20, 10. And 24, It's 12. And the first one is 0. Cumulative lift is the proportion of true positives predicted by the model divided by true positives predicted by baseline model. And we can drag down this formula. Here you can see the cumulative lift for our predictive model. Next, we are going to build our lift chart, and we will use these 3 columns here, and then insert, and let's arrange the scale here, and maximum is 100, minimum is 0, and let's change the title as lift chart. And as you realize here, we don't use the number of cases as x-axis, we use the percentages of top N records.